For decades, faster-than-light travel, often referred to as warp drive, has been one of the most captivating concepts in science fiction. However, recent advancements in warp drive research, particularly by NASA scientists, suggest that faster-than-light travel might be closer to reality than we once thought. In today's video, we'll dive deep into these groundbreaking developments, explore the science behind warp drive technology, and discuss the incredible implications it holds for the future of space exploration and humanity. So, without further ado, let's get started. NASA has recently made remarkable advancements in warp drive technology, driven by the innovative work of Dr. Harold "Sonny" White and his dedicated team. Dr. White, a NASA physicist, has spent years studying how warp drive, a concept born from theoretical physics and popularized by science fiction, might one day become a reality. His research builds on theoretical groundwork laid by physicist Miguel Alcubierre in the 1990s. Alcubierre's concept, known as the Alcubierre drive, proposed that a spacecraft could traverse vast distances by manipulating spacetime around it. The idea was to create a warp bubble that compresses spacetime in front of the spacecraft and expands it behind, allowing the craft to ride this bubble across space. In theory, this warp bubble could enable the spacecraft to reach speeds faster than light relative to an outside observer without actually breaking the universal speed limits set by Einstein's theory of relativity. However, early calculations revealed a major obstacle: the energy requirements. Creating and sustaining a warp bubble, according to initial models, would need an amount of energy equivalent to the mass of Jupiter, which is far beyond what our current technology can achieve. Recognizing this obstacle, Dr. White began exploring ways to make warp drive feasible. He proposed a critical modification to Alcubierre's model. Instead of a traditional spherical bubble, he theorized that a toroid, or donut-like shape, could dramatically reduce the energy demands by redistributing the geometry of the warp bubble. He calculated that this reconfiguration could lower the energy requirements from Jupiter-sized levels to something closer to 700 kilograms of mass, still a challenge, but far more achievable than Alcubierre's original model. Beyond the energy requirements, implementing Alcubierre's concept of a warp drive faces another major challenge. Creating a stable warp bubble requires exotic matter with negative energy density. This hypothetical matter, theorized to have negative mass, could provide the negative pressure needed to stabilize the bubble and manipulate spacetime on a large scale. However, exotic matter remains purely theoretical, with no experimental evidence confirming its existence, making it a significant obstacle to realizing warp drive technology. To test and refine these concepts, Dr. White and his team at NASA developed the White-Jude Warp Field Interferometer. This experimental device is designed to detect and potentially generate tiny warp bubbles in a controlled lab environment. Although still in its early stages, the interferometer marks an important first attempt to validate warp drive principles in practice. Success in producing even a small, stable warp bubble would be substantial proof of concept, advancing warp drive from a theoretical idea to a feasible future technology. Adding to these insights, researchers like Joseph Agnew at the University of Alabama are contributing further studies on Alcubierre's theory. He points out that although the energy demands remain high, the theory itself is mathematically sound. He also explains that a spacecraft within a warp bubble would essentially ride its own spacetime pocket, staying stationary within its local frame while achieving extraordinary speeds relative to outside observers. While NASA's work on the Alcubierre model is the most prominent approach to warp drive research, several alternative theories are being explored by scientists worldwide. Each of these theories offers a unique approach to solving the challenges of faster-than-light travel while adhering to known physical laws. One such approach involves the Casimir effect, a quantum phenomenon where negative energy densities appear between two closely spaced conductive plates. Scientists have theorized that if we could harness the Casimir effect on a larger scale, it could contribute to creating a warp bubble. However, generating negative energy at a macroscopic level suitable for propulsion remains a significant challenge. The Casimir effect has been observed in laboratory settings, but scaling it up to the level needed for space travel is a task that will require further advances in quantum mechanics and material science. Another intriguing approach involves the concept of extra dimensions. According to string theory and brane cosmology, our universe may contain additional spatial dimensions beyond the three we experience. If these extra dimensions exist, they could theoretically allow for shortcuts through space-time, similar to the concept of wormholes. In this scenario, a spacecraft could navigate through these extra dimensions to reach distant locations much faster than traditional travel. While these ideas are fascinating, there's currently no empirical evidence supporting the existence of extra dimensions. Dark energy is another area of interest for researchers exploring warp drive technology. Believed to drive the accelerated expansion of the universe, dark energy is one of the least understood aspects of modern physics. Some scientists hypothesize that if we could harness dark energy, it might be possible to create localized expansions and contractions of spacetime around a spacecraft. Despite these challenges, the ongoing pursuit of warp drive technology inspires new advancements in theoretical physics, engineering, and material science. Each new theory and experiment adds to our understanding of spacetime and the fundamental nature of the universe. The path forward may be complex and filled with unknowns, but the potential rewards are too significant to ignore. Thank you for watching. We hope you enjoyed exploring the fascinating world of warp drive technology and the groundbreaking research that's bringing science fiction closer to reality. If you found this video informative, don't forget to like, subscribe, and hit the notification bell so you don't miss any of our future explorations into cutting-edge science and technology.